Have you ever wondered what lies beyond the twinkling stars of the night? Since the very beginning of time itself, humanity has looked up to the cosmos with awe and curiosity. Today, on a very special episode of Destination Space, we're going to be looking at one of such very powerful tools which helps us curb our cosmic curiosity. This is Destination Space, the Giant Meter Wave Radio Telescope, or the GMRT. This colossal contraption, nestled in the serenity of rural India, is very close to the city of Pune. But this is no ordinary telescope. Forget peering through lenses, the GMRT tunes into the universe with a very different language. The language of radio waves. These invisible whispers carry stories from galaxies far away, just waiting to be deciphered. So how does the GMRT actually work? To understand the GMRT, myself along with a group of cosmic enthusiasts, shout out to Astro Club FC, set out to visit this magnificent telescope. Guys, here we are at the GMRT, the Giant Meter Wave Radio Telescope, and you can see the dishes right there. Here we are at the base of the telescope, and you can just see that is so big. So guys, today helping me is obviously Anuj. You know him from the podium perspective. So here we go for the GMRT tour. So also with me is Shayan. So you can see the vlog of this entire tour on his channel. Go subscribe to Shayan. The GMRT doesn't use light waves. It's all about radio waves. These invisible whispers carry stories from across different parts of the universe. But how do we gather this information and study it? Let's break it down. Imagine a giant satellite dish, like the ones you have at home, but way bigger. These 40-meter whoppers are designed to catch those radio waves, kind of like a giant ear pointed at the cosmos. The curved surface acts like a mirror, focusing all the incoming radio waves onto a special receiver at the dish center. This receiver then converts those radio waves into electrical signals, like translating an alien language. Now here's the cool part. The GMRT isn't just one antenna, it's an orchestra of 30. These 30 antennas are spread over an area of 25 kilometers. Together, they act as a giant web capturing radio waves. So as you can see, GMRT is arranged in an array. It's a Y-shaped array which is divided into many zones, which are center 1, center 2. We also have the east, west and the south zones. So as you can see there, this is the C3 antenna where you're standing at, which is part of the central zone. But here's the issue. Each antenna sees a slightly different version of the same signal. The trick is to combine all these different signals into one image. Think of it like a puzzle piece. Each antenna is like one puzzle piece, and together they reveal the entire image. So how do they combine all this information? The secret sauce lies in a process called correlation. Here's the deal. The GMRT compares signals from each antenna, looking for similarities. Imagine fingerprints. Each antenna gets a slightly different fingerprint of the same radio wave. By finding these matching parts, the GMRT can essentially combine the information and create a super detailed image of what's out there. Kind of like turning a blurry image into a high definition masterpiece. But that's not all. What makes GMRT truly special is that it operates on the meter wave band. Think of it like different radio stations. Each wavelength will carry different information. The meter wave band is like the oldies of radio signals. Distant objects and faint whispers. Too faint in fact that many telescopes can't even pick that up. So that is a huge advantage for the GMRT. Another advantage that it has is that it has less interference from human-made radio signals, such as the Wi-Fi signals or the data signals for our phones. So this gives GMRT a crystal clear view of the night sky. So with its unique focus on meter waves, its location with minimal interference and its teamwork of antennas, the GMRT unlocks a whole new chapter in astronomy. It's like having a powerful, high-fidelity radio set tuned into the universe's most fascinating broadcasts. So that was our visit to the GMRT. Now, the only question that remains is, why spend so much money constructing such a specialized equipment for astronomy? Simple. Because size matters in space. These antennas work together like a superpowered team, collecting more radio waves and creating crystal clear images. With this detail, scientists can piece together the secrets of celestial objects, like how they are made, what they are made up of, how they evolve. It's like having a front seat to the greatest cosmic show ever. And the discoveries are mind-blowing. We have mapped galaxies, unraveled the mysteries of pulsars, even peeked into the early universe. The GMRT is helping us understand the birth and death of stars, the evolution of galaxies, and maybe even answer the age-old question, Are we alone out there? All of it happening right in front of our very own eyes. And that's what makes it special. Well, that's it. Thanks for watching, and do consider subscribing if you like such deep dives into space stuff. Today we have taken a bit of a departure from our usual VO style, so let me know in the comments if you prefer this kind of videos. With that being said, I'll see you very soon in the next one. Thank you.